So in this part we have inference about two means, and this part we have dependent sample and test hypothesis for population mean from match pairs data. And then after that we're going to construct confidence interval as always. But this time this will be for match pairs data. And so here we have requirements. As always, first we have to see if do we have our requirements, and then we're gonna find the answer for this part, either rejecting null or not. So the first one, the sample is obtained using same thing that we had before, simple random sample, so we should have this one, or the data results from match pair design. We had these in the definition in chapter 1. And then second requirement, the sample data are dependent. So here we have dependent, and that is for sample data, is not for sample values. So this is different. So this is based on what data we have, and those data are dependent. The third one, differences are normally distributed. So here again we have normal distribution, and we had this part before, that when we have normally distributed, meaning that we do not have outliers, and also our sample size is greater than or equal to 30. So we have or in between. So you should have either the sample size, either having large sample size or having normal distribution with no outliers. We should have one of these two. And finally, the samples values. So this is same as we had before. Samples value are independent. But that means that sample size should be less than or equal to 5% of population size. So we had this part before. So the only part that we added was this one here, because we're gonna work on based on the data, given data. And after those requirements, now test hypothesis. Step 1, as always, we have two tail, left tail, right tail. So our null, we always have this mean of differences. This D is difference between data. By working on example, you can see what that is. So this is mean of difference. Okay, we have that one here. Mu D is the population mean difference, and that is for match pairs data. So for null and top, for all these three, we have this mean equal to 0. For alternative, which is second line, for two tail, again, as always, we have is not equal to. For left tail is less than. For right tail is greater than. And since on null we had this equal to 0, we have same thing for alternative. And then step 2, we should know what is our alpha. Step 3, test statistic. I'm going to use p-value approach again. So we have to find t here. T is equal to this d bar. D is differences between data. And this d bar is, after finding d, we have to enter all those data into our TI-8384 and find mean. So this is same as x bar. How we got the answer for x bar? We had to enter all values for x's and then find the mean. So divide by how many numbers you have. That way we can find this x bar. So that is exactly the same as this. We're gonna work on that part because this way gonna be a little bit confusing for you. Then divide by this S is standard deviation. Again, D is difference. Divided by square root of n, and is sample size. Okay, and then step 4, after finding the C here, we have to find p-value. So this is same that whatever we did before, we're gonna do same thing. For true tail, we have to multiply by 2, but for left tail, we're not multiplying by 2, and same thing for right tail. So for two tail, the answer is sum of these two tails. For left tail is what you have here on left side. This is area that we have on left. And right tail is, the answer is right tail area. Step 5. Finally, we can compare p-value with alpha. If p-value was less than alpha, meaning that we have to reject null. And step 6, state conclusion based on what you had in step 5. Okay, let's work on an example here. Example 1. Here we have 20 patients. And they had some kind of procedure, and after 3 months, the mean difference in hair density was 170.70. Now part A is asking what does it mean for this study to be a prospective cohort study. So we had this part in chapter 1. And the reason that this is cohort study is that because we have this procedure is for 3 months. So this is prospective cohort study because subjects were followed over a period of time, and that was 3 months. Okay, so I'm writing down part. Okay, so the reason is that subjects were followed for a period of time, which was here was given as 3 months. And our response variable was hair density. So this was measured. The part B, the question is, what is the variable of interest in this study? Is it qualitative or quantitative? So as I said in part A, we have response variable is hair density. And here it's asking what is our variable and what is we working on and we're trying to find. So again, our variable is hair density. Okay, it's hair density, and that is, let's see what that is. Okay, we have this one here. It's hairs in centimeters square. So obviously we can measure this one. That's why this is quantitative. Now part C, it's asking to find null and alternative to determine if hair density increased. Okay, so here we have increased, meaning that for alternative I have to use right shell. So first null, mean difference is equal to 0, and then alternative mean difference is greater than, because here we have this is given is increased, so it's greater than 0. What this means when we have this alternative, this mean difference is greater than 0. This one means I have difference computed as after minus before. That's why we have positive. So if I had before minus after, we're gonna have left tail, and instead of increase, we're gonna have decrease. In a part D, researchers indicated that the test for normality indicated it was reasonable to conclude the change in hair density is approximately normal. In this part we have normal, and we do not have outliers. So we do have that requirement. Does the evidence suggest that PRP injected increases hair density? So on top in part C, we had increase. Here also we have increases. So we're gonna use, meaning that we're gonna use same null and alternative. And we have to use this alpha. Okay, again, I have A here. So that is alpha, it's not A. So it's alpha is 5% level of significance. Okay, so I already have step 1 is on top. I have no alternative. I have step 2, which is alpha is 5%. Now step 3, find T using the formula that we had on first page. So it's the difference bar, and this one standard deviation divided by square root of n. Okay, so this was given by 170.70, and standard deviation was 37.81, and n, or sample size, was 20. So the answer here I got is 20.19. So we first work on this one, then I draw this one. Now this part, I'm going to use table and see if are we able to find the answer using table, or it's better to use TI-8384. So we can find the answer using table, but it's not easy to find, and it's not exactly what we want to. So where's my table? Okay, so our sample size was 20, meaning that degree of freedom is 20 minus 1 is 19. Okay, so 20 minus 1 is 19, so it's this one here. And what we got for T is 20.19. So that 20.19 is should be here in the body of table, but we do not have that number. As you can see, if I had a degree of freedom, for example, 2, here we have these numbers. I have 9 point something, 22 point something, but on this part, our degree of freedom is 19. And for this part, the largest number I can have is, here I have in this table is 3.883. I do not have 20.19. So our answer, so this falls beyond this 3.883. Whose right area is this number here on top, because we working on one cell. It's right cell, so it's right cell, meaning that I have one cell, and this is the answer that I have for this port is 0.0005. This means our answer is less than this, so our P, since this number is not equal to 20.19, and I worked based on this number, and I got this answer for P. So our P should be less than 0.0005. So this is the only thing that I can conclude using this table. I cannot say what our answer is for P. Now let's go back there and use TI-8384. I'm just writing what we had for this part using table. So from T distribution, okay, so from this table, what I used was degree of freedom 19. And also we had 20.19. This was in the body of table. So this 20.19 falls beyond the number that we had on table was 3.883. And for that port, right shell area was 0.0005. Okay, this means our p-value is less than 0.0005. Okay, after that we can decide if should we reject null or not. So comparing this with alpha, obviously this 0.0005 is less than 0.05. So we have to reject null. Okay, so I'm writing after this one, compare p-value with alpha. So we said that this p-value is less than this 0.0005. Okay, how I can write this? So we can just write this is less than. And this is .05. That's why we have to reject. No. So this was using table. Now using TI 8384. So TCDF starting with this point is on 20.19, comma, we have 1E99, comma, degree of freedom is 20 minus 1 is 19. So here we have TCDF, and we have lower is 20.19, upper 1E99, degree of freedom is 19. So here is the answer. We have to multiply this one by 10 to the power negative 14. So this answer is very close to 0, but it's not equal to 0, but it's very close to that. So I will write exactly what I have here. I'm not going to use this negative 14 power and writing all those zeros. Okay, so I'm writing exactly what I had on calculator for this part. I got 1.34. 08, again 08, 62, E negative 14. So obviously this one, this p-value, I can write this way, p-value is less than 0.000. Let's stop here because we don't need to write all these zeros. We can just say, okay, obviously this one is less than 0.0001. And then after that, compare p-value with alpha. So p-value, which is less than 0.0001, is less than alpha, that is 5%. So we have to reject. And now here, I want to write conclusion based on what we decided. So we rejected null, meaning that we have sufficient evidence. And our alpha was 5%. This was level of significance. To suggest that we had PRP injected. And this, since we rejected null, meaning that this increases hair density. You know, part E, how would the alternative hypothesis change if the differences were computed instead of after minus before that we had here? Having before minus after. Since this part alternative, here we had increased and our alternative was right tail, and we used after minus before. If we change this one, obviously this will change to left tail. So instead of having alternative greater than 0 on this part, we're gonna have less than. So the alternative hypothesis would change to this one less than. You know, next part, here we want to construct confidence interval. Again, we have to find lower bound and upper bound based on what alpha is. So what alpha is, or you may have confidence of. So let's see. So E1 minus alpha multiplied by 100%. So this, we had this one before. So what that one is, 1 minus alpha is For example, if this was given 95% and how we got alpha was 1 minus this, and that one was 0.95 is equal to 1 minus alpha, and then multiply by 100%, so this is 95%. So this is what that means. So nothing changed. Everything is same as what we did before. But on this part, we're going to work on mu d, mean difference. So it's given by lower bound as this d bar minus t times standard deviation divided by square root of n. And for upper bound, as always, we have to add. So instead of subtraction, we have to add here. And so our t is critical value. And we got the answer for t using degree of freedom, which is n minus 1. So this d bar is mean, and SD is standard deviation. And this is based on data, so this d bar is mean of difference data, and SD is standard deviation of difference data. Here we have this note that interval is exact when the population is normally distributed and approximately correct for non-normal populations. But the point is that we should have large sample size. So if you didn't have your population originally normally distributed, as always, you should have a large sample size. Okay, we're going to have one more example for this section. On this part, we have data. So a d bar and SD is not given. We have to find them. So the following data represent the molecular velocity in feet per second. So for each run, 2 measurements of the velocity were recorded using 2 different measuring devices. So we have whether those devices are here. We have A and B. So we have these 2. So first row is for A, and second row is B. And start with observation 1 to 12. And this means our sample size is 12. So started from this point up to this point, so n is 12. And part A, why are these match pairs data? So see here we're working on 2 measurements. That is the reason for this part, because we used 2 devices and we had 2 measurements. So because 2 measurements and those were from A and B. And these are in the same round. So for this one part, device A, we had this data in the first run, and then here for B, we had this number 793.2. Now part B, is there a difference in measurement between device A and device B? So here we have, it didn't tell us if this is increasing or decreasing, so it's asking if do we have any change. So is there any difference, meaning that our alternative is not equal to, so we're going to use two-tailed test because of having this word here, difference. And alpha is 1%. Okay, we're not going to work on box plot, but if you try to enter all these data and find 5-number summary and try to graph box plot, you can clearly see that we do not have outliers. So normal probability plot and box plot of the data indicate that the differences are approximately normal, distributed with no outliers. So this part is given. We know that this is normal distribution and we do not have outliers. So first we have to find difference between these two set of data. Here first I'm going to work by hand, and then I'll use TI-8384 to find difference and find D bar. Here first, so okay, I'm writing D here, so I'm using DI. So I start with 1, 2, 3 to 12. So the first column that I'm working on, this is D1. So D1 is 793.8 minus 793.2. So that is 0.6. So I'm subtracting. So let me write the first one. So DI, and here I is 1, 2, up to 12. And the first one, D1, is equal to A minus B. D2 is, again, A minus B. Let's use same thing here, A1, B1, here A2, B2. Finally, D12 is A12 minus B12. Okay, let me write the first one here. So here we have 793.8 minus 793.2. So this is equal to 0.6. This one, 793, this is part here, 0.1 minus 793.3. So this is negative 0.2. And here we have 793.5 minus 793.5. So this is 0. So I'm writing all these here. Okay, so here the difference between these two is negative 0.2. Here again, negative 0.2. Here is 0.2, negative 0.2, and this one is 0.8. Column 7, 791.7 minus 791.6. This is 0.1. This one negative 0.1, 1.1, negative 0.3. This one is negative 0.4, and here is 0. Into TI-8384, or you can add all these numbers and then divide by 12 to find D bar. So finding mean of difference. So D bar is, okay, writing all these. I'm not asking you to find the answer by hand. I don't want you to waste your time. So I'm adding, subtracting all these. It's better to know how to find by hand. What if you had like sample size 50? So plus 1.1 minus 0.3 minus 0.4 plus 0. Divide by 12. Okay, the answer here I got is 0.1167. Okay, so we're going to use TI-8384 and enter all these data into calculator. So use stat edit. And enter what we have for A. So the first row here from 1, 2, 3, 4, 5, 6, and also here we have 7, 8, 9, 10, 11, 12. All these for A into L1. So these are L1. And then here B is for L2. And after that, for L3, I highlighted this L3, and then I use second 1 minus second 2, meaning that I have L1 minus L2. I got these, so you have to highlight like that. And then here, use second 1 minus second 2. So I have this. So I have same thing because I repeated this part. I'm going to remove this L4. So I'm clearing L4. Okay, so we have this. Now, again, use stat, and we have to find a mean and standard deviation. So stat, calc, and then choosing the first one, var stat, enter. Here we have L3 because the column we're working on is L1 minus L2, which was L3. Enter, enter. So these are our answers. This export is, in this case, we work on D, so that is D bar. It's 0.11 after running is 67. And standard deviation is 0.4745, so I'm running to 4 decimal places. So I'm writing what formula we use to find difference. Was DI equal to AI minus BI. And here I was from 1, 2, and we had our sample size was 12, so this is up to 12. So using TI-8384, for D bar we got 0.1167, and standard deviation is 0.4745. Okay, now test hypothesis, starting with the first one. First step, null alternative. So our null is equal to 0. And alternative here, what was the question? Okay, this one we have here difference, so it's not equal to. And step 2, alpha is given. Alpha is 1%. Step 3, find T. Or T as D bar divided by standard deviation over square root of n. So this is, we rounded these numbers, but if I write this equal to instead of this, that is fine. That's totally fine. So 0.1167. Here we have 0.4745 over square root of our sample size is 12. I run the this part here and I got 0.852. So we have to find p-value. That's why we have to tell test. I'm going to use TI-8384 because using table it's kind of hard for you, and I don't want to make this more complicated. So let's use TI-8384. Since we have to tell, we have to multiply by 2. So multiply by 2 and work on one of the tails, either right tail or left tail. Okay, let me first draw this. Okay, so here for t we got 0.852, and here we have negative 0.852. If we have this positive for t, let's use same thing. Let's use this right tail. So I'm going to use this one. So it's 2 times. Here to find P, we have to use TCDF. So TCDF, first we have 0.852, 1E99, our degree of freedom is 12 minus 1, because our sample size is 12. So 12 minus 1 is 11. So whatever the answer is for this part, TCDF, multiply by 2. And I rounded, I got 0.4124. So this is the answer for p-value. Let's write up for here. So this is our p-value. Okay, then step 5, compare p-value with alpha. So p is 0.4124 and our alpha was 1%. P-value is not less than alpha. Do not reject. Meaning that there is no difference. So let's write conclusion here. So there's not sufficient evidence so our alpha was 1%. You don't need to write this one. You can write exactly what we did before. But I'm writing in different ways so you can see. So there's not sufficient evidence to conclude. So you can just skip that part and then write to conclude. So there is no difference. In measurements of velocity between device A and device B. Now, part C, construct 99% confidence interval above the population mean difference. So here we have 99% and obviously our alpha is 1%, which is same as what we had in part B. and degree of freedom, which is n minus 1 is 12 minus 1 is 11. And we have to find t because we want to find lower bound, upper bound. And first we have to find this critical values t. So here we have alpha divided by 2 is 1% divided by 2. That is 0.005. So finding t, the area is 0.005. So how we can find the answer for this part is, again, when area is given, we need to find t, you have to use inverse. So inverse t. Here, instead of using that part also here. So this is the answer for our t. Now we can find lower bound, upper bound over 99% confidence interval. So lower bound, I'm using these two here on top. The lower bound is d bar minus t times. As always, on top we have standard deviation, and here is square root of sample size. So upper bound, now we have to add. Okay, so d bar we got, where's d bar? Okay, I didn't write down for here. Let's write what we got for d bar on calculator. Right, okay, I don't have that for here. Oh, it's here. In port B, it's 0.1167 and standard deviation is 0.4745. Standard deviation 0.4745. And our sample size is 12. Okay, I rounded this one on top lower bound to decimal, and the answer is negative 0.31, and here is positive 0.54. Okay, so this is our interval is negative, and here positive. So we are 99% confident that the population mean difference, because here we have population mean difference, the measurement is between these two. And this was feet per second. Okay, I use this one that we have feet per second to write this part here.